Hey guys, so today we are going to be learning about functions. So a function is a relation in which every element in the domain is paired with exactly one element in the range. So that's really important. So a function is a relation in which every element in the domain is paired with exactly one element in the range. In other words, for each input, there's only one output. Each input, there's only one output. So let's see if we can determine which of the following relations is a function. So for every time you're trying to determine if it's a function or not, you need to look at the x values. When we're doing this, the x's cannot repeat. So your x's cannot repeat. So for set A, my x values are 1, 3, and 5. 1, 3, and 5 are all different numbers, so they do not repeat. So this is a function. It's a function because your x values do not repeat. Every input has only one output. Okay, so now let's look at set B. So remember, we're looking at just the x values. The y values are great, but when we're determining if it's going to be a function, we need to look at just the x's. So on set B, we have a 2, a 2, and a 3. Do any of those x values repeat? Yes, the 2's repeat. So because these 2's repeat, it is not a function. The input 2 has 2 outputs. The input 2 has 2 outputs. So now we're going to find the domain and range of set A and B. So domain are your x values and range are your y values. So it doesn't matter if it's a function or not, we can still figure out the domain and range. So for set A, 1, 3, and 5 are going to be in the domain. And when we write these, we use little what we call braces. They're squigglies, is the unofficial way. So they look, that was really bad. Try again. They look like this if you're going to draw them yourself. It just takes practice. Okay, so range are the y values. So in this case, our range, we have a 2, and a 6. Well, the 2, and the 6, these two 2's right here repeat. So I don't need to write them twice though. Your range is just going to be 2 and 6. If a number repeats, whether it's for the domain or the range, we don't write it twice or 3 times or however many. We're just going to write it once. Okay, now I want you guys to try B. I want you guys to see if you can figure out the domain and the range for B. So pause this video and see if you can figure it out. Okay, so you should have paused the video by now. And for our domain, we're looking at these numbers. So your domain should have been a 2 and a 3. Your range, we're looking at the y values, which is always the second number in our coordinate pairs. So we have a 4, a 5, and a 4. So your range is just 4 and 5. And make sure when you're writing your domain and range, it's smallest number to biggest number. So now we are going into tables. We can still figure out they're a function or not, and then we're going to find the domain and range. So it doesn't matter if it is a coordinate pair, like here, or if it's a table, like here. So we're still looking at the x values to see if it is a function or not. So on set A, determine if it's a function or not. So on set A, you should have determined this is not a function. And it's not a function because the x is repeated. Your x is right here, those 2's repeated. So now we're going to find the domain and the range. So your domain, we have 2, 1, 2, and 4. So your domain should be 1, 2, 4. Your range are your y values, 7, 6, 3, and 2. And remember, you're always going smallest to biggest. So 2, 3, 6, 7. Okay, I want you guys to try set B. Pause this video, figure out if it is a function or not a function, and then the domain and range. So you should have paused the video by now, and you should have figured out that by looking at the x's, right here, this one is a function. It is a function because 4, 7, negative 9, and 3, none of those numbers repeat. Your domain, smallest to largest, should be negative 9, then 3, then 4, then 7. Your range should be a 2, a 3, and a 7. Okay, so we've done coordinate pairs, we've done tables, and now we're doing what's called mapping, which you don't have to know it's called mapping, but that's what these little blobs are with the lines. So mapping can be hard to tell sometimes whether it's going to be a function or not. But if you're ever stuck, you can always make a table, a t-chart, of what's going on. So -2 and that goes to -1 means -2 and 1 are a pair. -1 goes to 0, 3 goes to 0, and 6 goes to 4. So when you're doing this, if you have to make a table, you're still looking at the x's to see if they repeat. So right here, do any of these repeat? So no, they do not repeat. So this is a function. And it has the same explanation as earlier, if you want to write that down again. So every input has one output. That's why there's only one line coming from each of the numbers on the left side. Okay, so now if we look at B, remember, we're looking at the arrows that are coming from the left side. So this one goes to this one. 1 goes to 0. Then 2 goes to 2, but 2 also goes to 3. So right here, where there's 2 arrows coming off of that number on the left, that 2, that means that this is not a function. That input of 2 has 2 outputs. And if you were to see that in a chart, that would mean 2 is 2 and 2 is 3. So right here on the left, that 2 repeats itself. Okay, then we have the vertical line test. And it says on a graph, the idea of single valued means that no vertical line would ever cross more than one value. More than one value. That's what the vertical line test tells you. If it does not cross more than one value, then it's a function. If it crosses more than once, then it is not a function. So notice how on this example on the left side, they drew this vertical line and it crosses not only here, but also there. So that is not a function. So let's figure out which of these below, which of these right here is not a function. So if I draw a line, a vertical line up and down, it only crosses one time, right about there. If I draw another vertical line, it crosses right there. So A, this one is a function. Remember, we're finding which one is not because of the directions. So B, if I draw a vertical line, it crosses twice right away, once there and once there. So it doesn't matter where I draw the vertical line for this problem, it's always going to cross more than once. So because of that, this is your answer. B is not a function. If you want to continue to check, C, you draw your line and it crosses once. Draw another one, crosses once. Draw another one, and it would cross once at the bottom. So this one's a function. And same thing for D. Doesn't matter how many lines I draw, each line only goes through that V-shaped function one time. Okay, which of the following is not a function? Your answer should be A. If I draw my vertical line, it crosses 2 times. All the other ones, if I draw it, it crosses 1 time. 1 time's okay, 2 times is not. Okay, and lastly, it says the relation represents the time spent exercising and the number of calories burned during this time. So this is just this is 3 ways you can represent it. So there's a table, there's the graph, and there's mapping. All 3 ways represent the same numbers in this problem. So if I just look at the table first, let's just look here first. My x's, do they repeat? No, they do not repeat. I have a 20, a 30, a 35, and a 60. So because right here, the x's do not repeat, x's do not repeat, it's a function. So if this one on the left is a function, that means that the graph's also a function, and that means that mapping is also a function when we're trying to figure this out. So there's other ways they could have wrote this as well. They could have also wrote it as ordered pairs like we did. So they could have written each of the numbers like this. So 20, 50, 30, 85, 35, 85, and so on. Those are ordered pairs. And they could have actually came up with a function for this. So they could have come up with something that looks like y equals mx plus b. And that would be an equation. So based on the information they've given us, we could figure out what the equation would be. We're not going to, but that's just another way they could do it. So you could see a table, a graph, mapping, ordered pairs, or an equation, and they could ask you to figure out if it's a function or not.